Okay, I believe I'm ready.
Thank you, sir. We're good to go.
Okay. Hello, students, and welcome to Friday Happy Hour. This week is the first week for the second mini semester. I am going to go over navigating your MyMathLab course, graphs of equations and writing equations. For the navigation on MyMathLab, I'm going to go over like the main tools that you will be using. For example, assignments and how to get help. Okay, and also some resources. So let's begin then, okay? Here we go. Okay, now I'm going to help you how to register because a lot of times students have a hard time trying to register to the MyMathLab because they haven't had they don't have an account yet. Okay, so when you click on when you go into the website www.mymathlab.com, it will take you to this page here. Okay, what you have to do, if you already had an account from previous semesters, right? You're gonna click here, just sign in, and you're ready for the course. If you're already gonna register for the first time, you're gonna click. I can put it here. If you don't have an account, you're gonna click on student. Once you click on the student tab, it's gonna take you to the next slide, right here. Okay, so it says that you're gonna need three things: your email address, your instructor's ID course, and an access code, credit card or PayPal. But the access code, you can get a temporary code, which I'm going to show you how to do that too. Okay, once you have all these three, once you have one through three, then you're okay to register now. So once you click on the register now, it's going to take you to this page, which is the next slide. Okay, it says here, enter the course ID or program ID from your instructor. In my case, I'm using one from that I just made up. Just recently. Okay, so that was my course ID. Okay, Isasi 77649. Once you click that, okay, after you enter your course ID, you're gonna hit continue. Once you click on continue, it's gonna take you here to register. Either you're gonna register for the students doing this for the first time on a Pearson account, or if you already have an account, you're just gonna log in. Okay, once you log in, and it's gonna take you to that course, and then you have to purchase a code again, or have again a temporary access code. But say you never had an account with Pearson, so you have to create it. If this is your first time you are using Pearson, create an account. So you're gonna click there and create. Now, all these boxes you have to are required. So that's required. You have to use an email address, username, a password. You have to re-enter the password, your first name. Your first name and last name has to be how it is on your school ID. That's required, and I believe that's a security question and security answer. Once, after you fill out the required information, then you're gonna agree, right? You're gonna click that box there. And if one of these pertains to you, you click on the box there. But if not, this one over here is optional, right? If you want to get receive information from about other Pearson products, you click there and then you create the account. So once you hit create account, you're in. Okay, now you need to pay for the course or get the access code. Now, here on this page here, you either can purchase it for $104.99, which is gives access to students for up to 24 months. And they say this is the most popular one because I believe you can take other classes or view other classes. Now for the $69.99 is only for 18 weeks. It's probably for one semester, okay? Like a complete semester, which is 16 weeks. Now, if you want to purchase the access code now, you either use the $104.99 or the $69.99. But most students, they wait and they get a temporary access code. If you want a temporary access code, so you click here. And then after it does that, it's going to give you a code, and all you do is enter it. Okay, so once you're in there, this is the page that you should see. Okay? All these are tools at your disposal. The ones that I'm going to show you right now are the assignments I mean, that's the main one because because when I teach, I mean, when I teach this courses on MyMathLab, I want the student on the first day of class to actually be already logged in and ready to work on the assignments. And then I can go over any one of these, I mean, specific tools that you have. For example, right, if you click here on assignments, right, you click here on assignments, it's going to take you to this page here, right, assignments. Then, like I said, this was from a previous semester, right? That's why everything is past due. But let's say that you click here on homework number 1. So if you click here on homework number 1, this is what you see. There's 15 questions. If you click here on question number 1, that's what you see. That's number 1 there. Okay. And then there's also some tutorial on how to navigate through your MyMathLab. For example, how to how to submit some of the answers and stuff. But here I was trying to get like a screenshot of when I clicked this arrow down of question help, it wouldn't let me. It wouldn't let me do that. So what's here is actually some help with this particular problem here. They're going to give you like another problem similar to this one. Okay, now it has help me solve this. They have to solve this step by step. It has view an example, and some has also videos. A video that you can see, and then somebody explains how to get the answer for this one or the help, or you can click on the as my instructor. If you do that, in most cases, I can say this with my class. I cannot help you here because how in the world am I going to respond to you? I can do it by emails, but what I would say, I'll send you a text and say, you know what, see me at my meeting at the meeting room, which is a platform that I use to actually help my students out and also for my office hours. So that's what I would tell you, or if I say something like set up an appointment. Right now the classes are online, but when we go back face to face, you can actually ask the instructor on those particular questions, or the instructor can actually help you there in class. Okay, now. So let me go back 2 slides here, guys. Okay, let me go back 2 slides because I had something to say about, okay, for example, here, accessible resources, you can have the ebook, you can have PowerPoints, you can have videos, you can go back and also, here the resources, it has a lot of stuff that you can use. And like I mentioned, the book, which is an ebook. Videos, PowerPoints, and other stuff to help you be successful in this course here. Okay, and also multimedia, same thing. So once you're in, like I said, my main goal is for you guys to be able to start, get signed in, register to MyMathLab, and begin doing the assignments. And all these, at your own time, you can go and click on them and see what they're all about. When I teach this class, at times I go and go over each one of these on the second day of class, once everybody's registered. This way I can explain that more in detail. But for the simple fact that for today I have an hour to actually go over, navigate through MyMathLab, and also go over the first week's lessons. And like I put here on this slide, I went over enough information to get you registered and begin working on your assignments, which is the main objective for the first week. There are many more helpful tools to assist the student. Okay, so that's, in my opinion, the most where students have a difficult time is trying to register. So I just help you that because most students, they don't want to know about other tools because they don't know how to get in there yet. So that's why I just went over up to this point on the navigating through MyMathLab. And like I said, later on the semester or later on the second day of class, I will go over some of those actual tools. Okay. So now let me start with the first. This is something from section 2.1. It's graphing linear equations, graphing by plotting points. Okay. So say you have to graph y equals to negative 2x plus 3, and they want you to plot points. Okay. So it's always wise to do a little table. You can do it vertically or horizontally. I prefer to do it vertically. Now, how many points do you need to graph? There's only 2 points that you need to graph, and that's it, just 2 points. Okay? But at times, some instructors and also the book, they want you to do 5 or 6 points, maybe for the practice. But here I did 4. But you only need 2 points to graph a line. Okay, what points can you use? Because at times students would say, hey, Mr. Isashi, well, what points should I use? I said, well, just use, whatever you want. But also be logical, because if you use 100 for X, then you're going to get a real big number for Y, which will not fit on your graph. So I say most of the times I like to use like -2, -1, 0, 1, and 2. But here for this case, because I only use 4 numbers, 4 values for X, I use -1, 0, 1, and 2. 0 is always a wise choice, okay, because that's easy to do to evaluate it at 0. Now, so I'm going to use these points here. So I'm going to evaluate this function or this equation at these X values, okay? So there's my equation again. So here, okay, I'm going to plug in the values for X. So in this one, I'm going to put here -1, right? -1 goes in there. There's your -1. Now, -2 times -1 will give you +2. So all you do is simplify here. So it's 2 plus 3, which will be 5. So when X is -1, Y is 5. And this is the order pair, the point, -1, 5. Now, I'm going to repeat the process for the next 3 values for X. So again, we have that function, right? So now I'm going to plug in 0, because now X is 0. So if it's 0, this will be 0 plus 3, which will be 3. So when X is 0, Y is 3. And what's my order pair or the point? 0, 3. And I keep repeating the process until I get to all the values that I use for X. But here, guys, you can actually graph it with these 2 points, and you get the same answer. Okay, but I wanted to use a little bit more points. So here I'm going to use 1 for X. You plug it in there. So -2 times 1 is -2. -2 plus 3 is equal to 1. So when X is 1, Y is 1. And the point is 1, 1. And now let's do it for 2. Right, so -2 times 2 is -4. -4 plus 3 is -1. So when X is -2, Y is -1. And there it is. So these are the points, or the coordinate, the points that I got to graph. So there's my graph. So there's -1, 5. And this is 0, 0, 3, right? I could have graphed it right here with 2 points, because you only need 2 points to graph. And then comes 1, 1, and then 2, -1. So all I do is connect all those points with a line. And that's how you graph, by plotting points. Okay, now let's do now let's graph another way. I believe by plotting points, I gave you guys enough info with one example. Now, we're still graphing linear equations, but now they want you to graph by using the slope-intercept form. If a line has a slope m and the y-intercept b, then it is a graph of the equation y equals to mx plus b. This is called the slope-intercept form. Okay, so how do we graph using the slope-intercept form? So here we have y equals to mx plus b. M is your slope. B is the y-intercept. Okay, and also b is also your starting point. So whatever this is, that's your starting point on the y-axis. You can actually go straight to the y-axis, right? Whatever b is, or actually by plotting the point 0b. Okay, now we also have to know what's the slope formula, because at times they might give you the slope, right? The slope, 2 points, you have to get the slope. So my m is my slope, right? That's my slope. And the slope is equal to rise over run. Graphing in this form, I'm going to be using my slope, using the rise over run, and then I'm going to use my b. Okay, so that's what I'm going to be using to graph in this form. Okay, now there are 4 different linear graphs. The first one, this is positive slope, right? Because how you do math, right? You do it from left to right, just like you read a book, from left to right. So from left to right, this line is increasing. So this is positive slope. which will be something in y equals to mx plus b. You see that the slope, the m, is positive. This one is going down right from left to right, so that means this is negative slope, which the m is going to be negative. That's why this will be something in the form y equals to negative mx plus b. But in this case, my b is also negative, right? But I'll get to you. I'll show you that later, because this is your b here, guys. That's your b, the y-intercept. Now, if you have a horizontal line, right? There's no slope there. There's no incline nor decline. It's just zero, right? So there's zero slope. So this is zero. These two are the same. They're zero slope. And zero slope means you don't have, the m is zero, so you don't have an x, because 0 times x is 0, right? So we only have a b. Or this can be any number. So when you have something with zero slope, the equation will be y equals to a number, or let's say the number is b. These are horizontal lines. And these are good to know, guys. These are very good to know. Because if you're graphing something on MyMathLab and you know that the slope is negative, but you have something positive, it means you're doing something wrong. Okay? Or if you have something that you're graphing, say y equals to negative 3x plus 2, you know that the graph must be declining because it's negative slope. That's a good way to check if you're on the right track. Now, if you have a vertical line, right? This is called undefined slope. Undefined slope. And this will be x equals to c, and this is going to be a vertical line, and b and c are real numbers. At times, I don't like to use, it depends on my audience, on my students. At times, students get confused when you have something like y equals to b, or x equals to c. That's why this means that b and c can be any real number, but at times this is confusing for students, because they say, oh, Mr. Isasi, there's too many letters, and I don't know what that means. So at times, I just put a number sign here, y equals to a number, like a number sign, okay? Or x equals to a number. Okay, now, later on in about 4 or 5 slides, we're going to get the equation of the line of all these right here. Okay, that's part of chapter 2. But for now, let's continue. So now they want you to graph the equation y equals to negative 2x plus 3. They want you to use the slope intercept form. Okay, so what's my solution? I need to find my, all right, I need to put it right in this form, right? So I need to find my slope, the m, and I need to, which is negative 2, and which is the rise over run, right? So if it's negative, it goes 2 down and 1 to the right. From where? From my starting point, which is my y-intercept, or the b. b is 3, so this is my y-intercept, 0, 3, and that's my starting point. So you start here, and then from there, you're going to go 2 down and 1 to the right. Okay, so here we go. So b is my starting point, so it should be about right there. That's my starting point, right? Then I'm going to go down 2, 1, 2, and 1 across. And then you do your line. If you notice, the slope is a negative 2, so which means it's going to be negative 2 over 1. And all these points will be on the line. 1, 2, 1. 1, 2, 1. 1, 2, 1. You see, guys? And then if I go the other way, right? If you have 2 over negative 1, the same thing. You want to go, you want to go up. If you want to make this positive and not negative, it'll be the same thing. 1, 2, and 1 to the left because it's negative. You see? 1, 2, 1 to the left. So it's very crucial to know how to graph in this form. And in my opinion, this is a very useful way to graph. I don't want to say easy, right? Because most students will say, yeah, well, you're the instructor. Everything's easy for you. But anyway, I've learned that you never say that this is real easy. I used to say that, but not anymore. Because it is easy for the instructor, right? Because we're the instructors. But it might be horrifying for the student because they don't really get it. Okay, so that's why I learned not to say that no more. That is real easy. I just say that it's a good way to graph. Okay. Anyway, let's graph this one here. So again, the same procedure. You have to find the m and the b, the y-intercept. So right, so we know that this is my slope, right? This is my m. It's 3 and it's 3 over 1. Why do I put it as a fraction, as a rational number? Why? Because this is my rise, this is my run. And then, right, 3 up and 1 to the right. Now, my B is -5, so that's my y-intercept, and that's my starting point. This is always your starting point, right? The B is always your starting point. And again, you don't have to put the point 0 and -5. For example, if I was doing it without doing all this work, I would just go here. This is my starting point right there, right? You click there. Then it means a 3, and then you're going to go up 3, 1, 2, 3, and 1 across, right? 3 up and 1 to the right. There it is, right? And you keep going, 1, 2, 3, 1, 1, 2, 3, 1. You see, you got the same slope. So that's why, guys, I put all this so you guys can see actually what's taking place. But you can actually graph it right off the regular equation. Again, this is my starting point, the B, which is the y-intercept, -5. And the positive slope means that you're going to go up 3 and 1 across. 1, 2, 3, 1 across, and you connect the dots with a line, and that's your line. Now graph y equals 4. Hey guys, remember when I did those four basic graphs, the positive slope, negative slope, and the horizontal line and vertical line? This is crucial because we should remember that that the line is going to be horizontal because every y value is 4. That's what that means. Every y value is 4. So here, guys, we don't have no slope, right? There's no m there. There's no mx. So that means it's 0. That means it's going to be a horizontal line. And this is my y-intercept, the B, this is my B there, right? And that means to graph it, starting point, 0, 4. This means that every value is 4 for the y value, right? So it means it's going to be a horizontal line. There's your line. Okay. Observation. When the equation is y equals to a number, you see, guys, here I put a number because I was setting up for this slide here. Y equals to a number, horizontal line, at that number. So for example, right, y equals to this number, it's going to be a horizontal line at that number, which is 4. Okay. Now x equals -2. If we notice, we don't see the y equals to mx plus b. All right, we don't see no y. That means this is going to be a vertical line on the number x equals -2. Okay, solution. Find the slope. So x equals -2. The slope is undefined, right? Because it's vertical. So then, vertical line. So vertical line at x equals -2. So it's going to be the vertical line here because this means that all the x values are -2, right? So that's my line. Observation. When the equation is x equals to a number, vertical line at that number, which was -2. Okay? Okay, now. Graphing linear equations. Okay, now this one here is not on the y equals to mx plus b form, right? So then solution, we have to put it in y equals to mx plus b. Y equals to mx plus b. Okay? So set up the equation y equals to mx plus b. This is called slope-intercept form. So I have to put it, I believe this is called general form. So you have to put it in the slope-intercept form. You have to put it in this form. So we have to isolate the y. So we start by adding 5x to both sides. Okay? So if we add 5x to both sides, this will be 0, and then 5x is added over here to the right side. Then we're going to divide everything by -2. Right? So -2 divided by -2 is 1. 5 divided by -2 is -5/2. And -10 divided by -2 will give us a +5. Okay? So my slope is -5/2, which means I'm going to go 5 down and 2 to the right. Or you can say 5 up and 2 to the left. It doesn't matter. But most of the times, if it's negative, I like to say that the numerator is the one that goes up or down. So the 5 right is negative, so the 5 down and 2 to the right. From where? From the y-intercept or from the b. So again, you start it. So this is my b, right? So this is my, we start here at 0, 5. Then I'm going to go down 5, right? I'm going to go down 1, 2, 3, 4, 5, and 2 across. 1, 2. The point should be about right there. Connect the dots with a line, and that's your line. Okay, now, hey guys, remember those lines that I told you that we were going to get the equations of? Okay, now I believe I have given you enough info to get the equations, write them in the slope intercept form. What do we need? Solution. We need y equals to m. Why we want it in this form? So we need the m and the b. The m is rise over run, which is the slope, and the b is the y-intercept. So on this one, on number 7, what's my y-intercept? It's 1. So b is 1. Now, you have to get, hey guys, when you have something like this, you have to get another point that goes exactly to one of the corners. You see, for example, I cannot use that point there. I cannot use that one either, nor that one either. So I have to use this point over here, right? This point over here, or maybe I can use this point over here. So I decided, right, rise over run, I decided to use this point here. So then, how many, right, the rise is up or down, so how many does it go up? 1, it goes up 1, 2, 3, right? And you're going to go 1, 2, 3, 4 across. So it's going to be up 3 and 4 across. So this is my rise. My rise is 3 and my run is 4. So that's my slope. Now I have enough info to write the equation in the slope intercept form. Right? So my m is 3/4, my slope is 3/4, and my b is 1. That's my equation. Okay. Now look at number 8. My b is -2. My rise over run side, so we have to pick another point that goes exactly to one of the corners. You see, not that one, not that one, it's got to go all the way over here. Right? Or maybe, you see, we cannot go this way because there's no, they don't go right through the corner. So then that means, right, rise over run. So this one, right from this point, it goes down. How many? 1, 2, 3, 4, 5. And then it goes 1, 2, 3, 4. So this will be -5 over 4, right? So that's my slope. So I found my b, I found my m. Plug them in, and you got your equation. You see, my m is -5/4, and my b is -2. So that's the equation for number 8. Number 9. Remember, guys, with horizontal lines, it's going to be y equals to a number, right? My b is -3. So for horizontal lines, this is zero slope, right? There's no incline or decline. So it's going to be, again, observation, horizontal line, y equals to b, or y equals to a number. My b is -3, so we have y equals to -3. Same thing for number 10. For number 10, there's no y-intercept. Vertical line at x equals c, right? So here, there's no y-intercept. It'll just be x equals c because that's a vertical line. So it's very, very important for you guys to know these 4 graphs. When you graph your linear equations, there's no other way it can be. It's either going to be positive slope, negative slope, zero slope, or undefined slope. It cannot be any other thing. Okay? So it's wise to know those 4 graphs. Okay, now, graphing linear equations by finding the x and y intercept. Okay, now these are the rules that you have to know. To find the x-intercept, you let y equals 0 and solve for x. And I'm here on the reading here from the definition that I put there. To find the y-intercept, you let x equals 0 and solve for y, right? So all you do is reverse them. This is to find the x-intercept. This is to find the y-intercept. So now, solution. First, find the x-intercept, right? So what does it say? Let y equals 0 and solve for x. So this is my equation, so I bring it down, right? So I have to plug in 0 for y. So that's 0, so we have -5, x equals to -10. So we divide both sides by -5, x equals 2. So that's my x-intercept. Okay. Now we have to find, right? Oh, I mean, I put it here. X equals -2. X equals 2, I'm sorry. Now let's find the y-intercept. So for that, we have to let x equals 0. So this is a value for x here. So we're going to put 0 for the x. We get -2, y equals -10. We divide both sides by -5. By -2. So the answer will be y equals 5. So the y-intercept is 0, 5. 0, 5 is up here. We connect the points, and that's my line. Now, on my next slide, I'm going to show you the very same thing, but without doing all this work. And I have a name for this. Okay, I call this a cover, and I do it in the boards, covering with the hands. Okay. One time, a student asked me, "Hey, Mr. Isashi, well, where does it say cover in the book?" I said, "There's no such thing in the book as cover." But and then he mentioned, "Well, why do you show us that way?" Okay, I said, "Just hold on. Okay, you're gonna like this, because this, guys, you can do it without actually showing no work. Okay, here's how it's done. To find the x-intercept, right, you let y equals 0 and solve for x. Okay, so here we go. I don't even put all this here, guys. What I do, let's pretend that this is the original, right? So all I do is cover the y, right? Because if y is 0, that goes away, right? Because -4 times 0 is 0. And then in your heads, you can actually solve for x. How do we solve for x? We divide both sides by 3. X equals 4. You see, guys, minimal work. So that's my x-intercept. So it's going to be 4, 0. Same thing with finding the y-intercept, right? So you let x equals 0, and again, you can do both of these right from here, right? So for the y, I will do is cover this part here to find the x-intercept, and now for the x, right? You do the same thing. I mean for the y-intercept, you cover the 3x, and now this you can do it in your heads. You divide both sides by -4 in your head, so y equals to -3. So that's my y-intercept. So 0, -3. And then we connect the dots or the points. Hey guys, all my students, once I teach you like this, guys, they know how to do it, and they do it that way. But you might say, what happens? But first, I tell them, make sure that both of the coefficient of the x and the y go into the constant term over here. For example, does 3 go into 12? Yes, it does. Does 4 go into 12 or -4 go into 12? Yes, it does. So I know you can do the cover or finding the x and y intercept. For example, if this was like 11, this would be real hard to graph it that way. So then I would recommend to put it in slope intercept form, y equals to mx plus b, and graph it like that. Okay? Okay, now, the next topic is finding the slope of a line through 2 points. The slope of a line through 2 points, this is called x of 1 is y of 1 because this is considered point 1, right? So this is point 1, that's going to be x1 and y1. And this will be point 2, so it'll be x2, y sub 2. Where x1 cannot equal to x2. Why? Because if these are equal, they're going to be undefined, right? Because say these are both 3. What's 3 minus 3? 0. Something over 0 is undefined. Okay? That's why it tells you that x1 cannot equal to x2. So find the slope of the given line. Okay, so this is number 13, number 14. So now, okay, guys, I mean, I did it like 3 or 4 different ways. I mean, like the setup here. So, and then you choose whatever is easier for you. I believe number 15 and 16 on the next slide is going to be easier because it's more visual. Here, guys, you call this x1, so you're going to put 9, 0 there. And 12, 12, right? So this is 12, 12 because this is point 1. So it pertains to x1, y1, and this is point 2, pertains to x2, y2. So now my slope, right? So y2 is what? Y2 is 12, so it's going to be 12 minus 0. And 12 minus 9, because this is x2 minus x1. So it's going to give us 12 over 3, which simplify, x equals 4. I mean, the slope is 4. Very basic, straightforward, just by knowing how to use the formulas here. Now 14, right? Same thing. So here, right, the solution is x1 and y1. I put them this way. This is my x1. This is my y1. This is my x2, which is a -4. And this is my y2, the 11. So y2 is 11, right? So it's going to be 11 minus -2. And -4 minus -5. So we know from other previous courses or high school that when you have a negative times a negative or two negatives back to back is equal to a positive. Or this is like a -1 there, right? -1 times -2 is +2. Same thing over here on the bottom on the denominator. That'll be +5. So that will give us 13 over 1, which my slope is 13. Okay. Now, 15 and 16. after I do these two guys, I'm going to show you an observation. The observation is to eliminate the work, but understanding the concept at the same time. Okay. So, but I have to show you this first before I can show you the observation. So again, just do it this way. So now these, I did them a little bit different, right? So I put them here. My x1 is 5 for the people that need that actually need that are more visual. My y1 is 3, right? My x2 is -7. My y2 is 3. Now all we do is plug them into the formula, right? So y2 is 3. y1 is 3. x2 is -7 and x1 is 5. So, right? So we get 0 over -12. So my slope is 0. Okay. Now observation. This is what I'm telling you about. Before you actually do any work or on anything, you do this. You ask yourself, do the x values repeat? No. Right? So you can proceed. Do the y values repeat? Yes, they do. So then that'll be 0 slope without doing the work. So you know it's 0 slope. That's what it says here. Observation when the y values of the 2 points repeat is going to be 0 slope. Okay? If we apply this concept here, right? By observation, right? Do the x's repeat? Yes, so you don't have to do all the work. We know that it's going to be undefined slope because if the x is right, x1 and x2 right, if these repeat, what's 1 minus 1 is going to be 0, right? So this, you don't have to do no work, just undefined. But actually some instructors, I want you to do all the work, right? Show the work. So let's show the work. My x1 is 1, y1 is 2, my x2 is 1, and my y2 is -6. We plug him in there, right? We know that y2 is -6, so it'll be -6 minus 2, because my y1 is 2. And then 1 minus 1, right, is 0, so we get -8 over 0. So that's undefined slope. Which means, right, it's going to be a vertical line. And what's the observation? When the x values of the 2 points repeat, undefined slope. So you can actually, when you do the homework, when you have to find the line between 2 points, you can actually do that before you actually do all the work. You check the x values. If they repeat, it's going to be undefined slope. And if the y values repeat, it's going to be 0 slope. And if none of the x's or y's repeat, then you can proceed and actually find the slope. Okay, that's only something like to think of observations. Okay, now also I like to come up with a lot of observations when I teach my classes. Why do I do that? Because when I was doing my master's program at UTEP, the instructor will put, like, for proofs themselves, they will put observation. And at times, I didn't really meant what he was talking about until one day I asked one of my instructors. He said, just observation, there's something that's kind of just by observing you should know without doing any work. And that's why I like to use that way of teaching. But I always show the concept first, or the concept of the topic, and then if there's observations to show, then I'll show you observations. Okay, but you do all the work, guys, because every instructor is different. Okay, so you do what the instructors want you to do. Okay, now find an equation of the line with a given slope and passing through the given points. This is called the point slope formula. Okay, which is y minus y1 equals to m x minus x1. To use this formula, you must have the slope and only one point. That's why it's called the point, which one point, and the slope. That way you can get the equation. So here it says find an equation of the line with a given slope and passing through the given point. Okay. So we're going to use the y minus y1 equals to mx minus x1. The y and the x, you don't substitute nothing there, only for y1 and x1. Okay. So we know that x1 is -3. We know that y1 is 2, right? That's my slope. So I'm going to plug everything into the formula, right? My y1 is 2. Plug it in there. My slope, my m is 4, right? Plug it in there. My x1 is -3. It's always wise to put it with parentheses, right? Because at times students, because it's already all negative, they keep it negative. They just put x minus 3, and that's wrong. That's why I put it in parentheses to signify that I'm plugging in the x1 value here. Now again, 2 negatives becomes a positive. Now I'm going to distribute. 4 times x is 4x, and 4 times 3 is 12. Then I want the equation of the line in the slope-intercept form, right? Which is y equals to mx plus b. So the y has to be isolated. So I'm going to add 2 to both sides. So 2 plus 12 is 14. So that was my answer. Y equals to 14 to 4x plus 14. Okay, now find an equation of the line passing through the given points. Now here, guys, they don't give you the slope, which means you have to do a little extra step, and that's it. You find the slope, and then you use what we did in number 17. Okay, so what's my solution or my strategy? First, find the slope, then use the point slope formula to find the equation. Okay, there's my slope formula, and there's a point slope formula, right? So first, I have to find my slope. So we have -5, -2, right? That's the first point, and -4, 11. So we know, right? So again, this is x1, x sub 1, y sub 1, x sub 2, y sub 2. And at times, we ask me, Mr. Sassy, does this have to be the first point? No, if you want, you can switch them. It doesn't matter, as long as you call one point 1 and the other point 2. So since this is first, I always like to call this point 1, and so I make the notation that this will be my x sub 1 and y sub 1. So x sub 1 is -5, y sub 1 is -2, x sub 2 is -4, and y sub 2 is 11, right? So now we plug them in. This will be 11 minus -2 and -4 minus -5. And I believe this is the one that I did earlier that we found the slope. So we got 13, right? Now we have to apply the point slope formula. Now here's another, we know that x1, right? We're going to use point 1. Here, guys, at times, students ask me, Mr. Sassy, well, what point can I use? You use whatever point you want. You could use point 1 or point 2, it doesn't matter. Okay? You use whatever point is best for you. At times, students try to stay away from negative numbers because they say that kind of messes them up. But I just got the first point anyway. Okay? And we know that my m is 13. So all we do is plug into the formula, right? My y sub 1 is -2. My slope is 13. And my x sub 1 is -5, right? So this becomes, right? 2 negatives become positive. 2 negatives become positive. Now we get to distribute. 13 times x is 13x, and 13 times 5 is 65. We have to put it in the slope intercept form, so we have to subtract 2 to both sides. So, right, so it'll be 65 minus 2 is 63. So this is the equation of the line that I'm looking for. Y equals to 13x plus 63. Okay, now, here comes parallel lines and perpendicular lines. When two non-vertical lines are parallel, whenever they have the same slope. So parallel lines have the same slope, right? So to simplify this parallel lines have the same slope. And two non-vertical lines are perpendicular whenever the product of the slope is -1. Or an equivalent definition for perpendicular lines is the non-vertical lines whose slopes are negative reciprocals of one another. Or some even say the opposite reciprocals. What does that mean? Okay, right now I'm going to show you what that means. First of all, I'm going to show you examples of parallel lines, then I'll explain, right, what the perpendicular slopes mean, right, when they're perpendicular. So they're going to give you two lines. So I call this line 1, that's why I call it y sub 1, and line 2, y sub 2. So all you do is compare slopes, right? Compare slopes. Are they the same? Yeah, same slope. Which means M1, because this is line 1, I call it M1 is 3, and M2 is 3. So these lines are parallel. All you do have to compare slopes. Let's do another example. Line 1 is -2x plus 1, and line 2 is -2x plus minus 20. So again, right, they're the same slopes, -2 and -2. So these are also parallel lines. Now, examples of perpendicular lines. Okay. Now, here we go. Line 1 is 3x plus 6. Line 2 is -1/3 x minus 7. So if we compare the slopes, right, are they the same? No, that means they're not parallel. Are there M1 is 3 and M2 is -1/3? by applying the first where it says two non-vertical lines are perpendicular whenever the product of the slope is -1. If you multiply the both slopes, you -1, yes, it will. Okay? The product of the slope is -1 because 3 over 1 times -1 over 3 will give you -3 over 3, which would be -1. Or they're negative reciprocals of one another. For example, what's the reciprocal of 3 over 1? Right? Negative 1/3. But when it's negative, all you do is switch the sign on the other one. Okay? Look at this one here. Again, first we check if they're the same. Then 1 and 2, we have y1 equals, line 1 equals to 5/4 x plus 6, and line 2 equals to -4/5 x minus 7. So first we find out if they're parallel. No, they're not. So we know these are going to be perpendicular lines, right? Because what's the opposite reciprocal of 5/4, right? The opposite means opposite sign. And what's the reciprocal of 5/4 is 4 over 5. So I know these are perpendicular lines. And if you multiply them, right, it's going to give you -1. Okay? So I gave you two examples of perpendicular and parallel lines. And I believe that's all you know. I mean, that's all you need because I just gave you two examples, and I believe you'll be able to understand this these parallel and perpendicular lines if they're parallel perpendicular. Okay, when you're given two lines. Okay, now why are these crucial? Because now they want you to find an equation of the line with the given conditions, which means through the point 34 and parallel to the line 4x minus 2y equals 5. Because here it's hard to know what the slope is, right? Because I need to find my slope, right? And then same slopes, right? So these, so this line has to be parallel to another line that passes through the point 34. And this is kind of hard to show you here in a PowerPoint, but in an eraser board, I can show you exactly what they're talking about, and that's what I usually do when I teach this concept here. But anyway, my solution is first find the slope of the line by rewriting in slope initial form. So I want to write this line, the 4x minus 2y equals 5, in the form of y equals to mx plus b. Okay. After you found the slope, use the point slope formula, right? Because same slopes, right? Parallel lines have the same slope. So whatever slope I find here, that's the one I'm going to use for the other line. I mean, for the other point, and by using the point slope formula. Okay, so let's execute the plan here. So I have to put it in slope initial form. So I subtract 4x from both sides. So it leaves us with -2y equals to -4x plus 5. Then we divide everything by -2. So we get 2x because -4 divided by -2 is 2. 5 divided by -2 is -5 over 2. We don't care about the b or the y-intercept. We only care about the slope. So my slope is 2. Okay, now I'm going to use this formula to find my equation, right? Now we have m equals 2, the slope is 2, and the point is 3, 4. Which means this is my x1, and that's my y1, right? 3 and 4. And there's your slope, so just plug them in. And this step, we already done it earlier in previous slides. That's why in math, it's always, math is like a stairway. You have to know foundations to keep going. You have to have a concrete foundation every step of the way, or else your math foundation is not gonna. It's gonna fall, which means that that you didn't learn you don't have a good foundation in math. And most of the times, what gets most of the students is the basic algebra. Okay, but anyway, all we do is plug them in. Now we distribute. We distribute, right? So then we get add 4 to both sides. So we can get y equals to 2x minus 2. So that's my answer. My equation, right? Now I saw something in the chat that you can use y equals to mx plus b. And I truly believe, this is my opinion. I always tell my students to do it that way. But I want to do how the book does it and how MyMathLab does it. But this is how I would explain it. Another method. Now we have m equals 2 and the point 3 fourths, right? Oh, what did I do here? Let me Okay, let me go. I did something wrong here. Let me see. Okay, here we go. Okay, I'm sorry about this, guys. Now, so I want to put it in this one, right? So I'm going to solve, right? I already know what my M is. My M is 2. Now I need to find my B. So if I solve for B here, we're going to subtract mx to both sides. So B equals to y minus mx. That's what we use. B equals y minus mx. In my opinion, it will be much easier. I mean, that's my opinion. So we know that x1 equals 3, or x equals 3, and y equals 4, and that's my slope. So my y is 4, my slope is 2, and my x is 3. Plug them in there. And you know, this will be 4 minus 6, which would be negative 2, right? So the answer is negative 2. So I have my m and I have my b. Right? All we do is plug them in, and you get your equation. See, same thing. So I always try to give students like 2 or 3 different ways to get the answer. And I always advise them, I always not advise them. I always let them know that you use that for them to use whatever is easier for them, because it's not about me, it's not about the instructors, it's about the student. So this way they have different methods to actually get the same answer. So I let them know that they can use whatever is easier for them. Okay. So now number 20. Remember number 19, it was finding the line that was parallel. Now this is perpendicular. This requires a little bit more work, only one extra step. So solution. We want you to find that goes through the point 6,8 and perpendicular to the line negative 2x plus y equals negative 3. Okay, now. So solution. First, find the slope of the line by rewriting the slope in this form, right? So I want to put the negative 2x plus y equals negative 3, place it or rewrite it in the slope intercept form. That way I can get my m, which is the slope. After you find the slope, use negative reciprocal for the perpendicular slope. Then use the point slope formula, or the one that I just showed you, the b equals to y minus mx. So first, I need to solve for y, right? Have y equals to something, mx plus b. So we add 2x to both sides. So I know my slope is 2. But remember, if they wanted a parallel line, right, then we will use the same slope like we did on the previous slide, on number 19. But now they want you to find the line that's perpendicular. So what's the opposite reciprocal of 2? Negative 1/2. So this is the slope that's perpendicular. This slope is perpendicular to this one over here from that line. So now we use now we have my m equals negative 1/2 and the 0.68. So we're going to use a y minus y1 equals to m, x minus x1, right? So this is my x and my y, 6 and 8. There's my slope. So we just plug them in. So here first I need to distribute. Right, so negative 1/2 times x will give us negative 1/2 x. Negative 1/2 times negative 6 will give us positive 3. Now we're going to add 8 to both sides. And it will be y equals to negative 1/2 x plus 11. This is a line that we're looking for. Okay. Now, how do you apply this in real life? Okay, this is, I believe, something from 2.3. Okay, it says here. The manufacturer suggested a retail price, MSRP, for a base model 2016 Toyota Prius is $25,035. And it is expected to be worth $14,150 in 4 years. So this is 3 parts, and this is actually one of the homework problems from the book. For A, they want you to find a linear depreciation function for this car. Hey guys, all this means is to find the line in y equals to mx plus b. That's all it means. And after you get the line, they want you to estimate the value of the car in 5 years from now. B means all you do is when you find the line in y equals to mx plus b, for B part, it means that you plug in 5 for the x, and whatever answer it is, that'll be your answer for B. And C, at what rate is the car depreciating, that's your slope. Okay? But here, a mistake that students make is that they put negative. You don't have to put negative because we know it's depreciating means negative. Okay? That's an overview. So now let's execute it. Solution, need to find 2 points. So from the given information, we have to find 2 points. Okay? When the car is brand new, right? The car is brand new, or I believe this problem was made in 2016, right, from the book. So in 2016, right, this book is brand new, right? So when it's brand new, it means that no time has passed. That's why x equals to 0. So this is my original price is 25.35. So y equals to 25.35, right? When x is 0, that's my y, which was $25,035. That's my first point. Now, my second point here is also a misconception here. Students, they want to put 2016 here. Then they want to put 2020 on the next point, which is completely wrong. That's why it says here, before it starts, right, that's the original price. That means that x must be 0. Okay, that's why it's 0 there. Now, so for the next point, right, if 2016 to 4 years later, so that's going to mean this is going to be 4. I'll put here and write 4, and the price, the y is 14,115. So these are my 2 points. Now, all you do is what we've been doing earlier. I think throughout most of this, PowerPoint. Okay, now need to find the slope and y-intercept. So I need to find my m and my b. So that's how you find your m, right? Which is this is the first point. This is my second point. So it's going to be 14,115 minus 25,035, and 4 minus 0. So you get negative 10,920. We divide by 4. So this is my slope. So this means, guys, that the car is losing value at $2,730 per year. Eventually, this will be the answer for C, okay? But let's not jump the gun here. Now, here, guys, I'm not going to use the slope point formula. I'm going to use the b equals to y minus mx, okay? Because in my opinion, it's easier, less work, and also you'll be able to use a calculator when you actually when you take 1324. The basic calculator is permitted. So all we do, guys, right, is I'm going to plug in, right, my y is 25,035. There it is, right? That took the place for y. Minus my x, right, is 0, so 0 goes over here where the x is, and my m is negative 2730. So that's my b. Okay, now heads up, guys, like observation, okay? But let's get the equation first. So my slope is negative 2730, and my b is 25,035, right? There's my m, that's my b, so we plug him in here, right? So that's my equation that we're looking for. Okay, now, because remember, guys, what's the observation here, guys? We're not doing no work here. We should have known that this is my b, right? Because at this point is 0, 0, right? This is my b, right? When you have something in y equals to mx plus b, this is my y-intercept. So we should have known that this will be my b value. Then I didn't have to do all this work here, just by knowing certain concepts. Okay. But anyway, I did the whole work just in case you didn't recognize that 25,035. That the 25,035 is my b, or the y-intercept. So what's the answer for A part? Is the equation that we found. F of x equals to negative 2,730 x plus 25,035. Estimate the value of the car in 5 years. So here, all we're going to do is evaluate at f of 5, which means I'm going to plug in 5 for the x there. We use a calculator, guys, so we get this answer. So f of 5 is 11,385. And if you actually keep subtracting 2730 from the original price, right? Every time, so on the 5th year, this is how much will remain the worth of your car, of the car that being considered here. So the car will be worth 11,385 in 5 years. So for C part, right? Here's another mistake that students make when they plug it into MyMathLab. What is the slope, right? The slope is negative, right? But here it's already saying that it's negative by every time something depreciates, it means it's negative. And most students would put negative 2,730. That's why it's wrong. The answer is positive 2730 because this means it's already depreciating. Okay. And I believe, do you guys have any questions? Because I believe that's the end of the PowerPoint. Yeah. Let me
Anyone have any questions for Mr. Azasi?
stop sharing here.
Thank you, Mr. Azasi. So,
Oh, you're welcome.
it
You're welcome.
was a wonderful presentation. If there
Oh,
is
thank
no
you.
further, if there is no further questions, I'll go ahead and I'll wrap it out right now. So I would like to invite you to Monday TV, which is going to be on EPCC Culinary Arts. They're going to be sharing with us some pasta salad and a bacon pesto spinach salad. So it's going to be pretty interesting there. And then also next week, we're going to have Happy Math Hour. We're going to have Math 1314, Properties of Logarithms, Exponential Equations for Math 1314. And then on Math 1324, we're going to have Writing Exponential Equations into Logarithmic Form, Solving Exponential and Logarithmic Equations. Ooh, that's a mouthful, isn't it? To answer your question, Edna, you can get it emailed. You're just going to have to email Mr. Azasi first, and he will be more than happy to send you that PowerPoint. Again, thank you everyone for coming. Thank you, Mr. Azasi, for helping us out and sharing your knowledge with us. And I hope everyone has a good day.